All right, today we're going to be looking at a different titration. In our previous recording, we looked at the titration of potassium hydrophthorate or potassium biphthalate. Basically, that was where we used sodium hydroxide, it was an unknown solution, and then we titrated that against the KHP in order to figure out what that unknown solution was. Today, we're going to do kind of a more classic titration where we're going to titrate an unknown hydrochloric acid solution, and we're going to titrate it with a known sodium hydroxide solution. So we have our unknown HCl solution here, and we have our known sodium hydroxide solution here. So all we need to do now is set up our burette like we did before. So we're going to go through this in a fairly standard manner. We're going to use our burette clamps here. We're just going to put it right on the stand, so we have our burette stand set up. And if you remember from before, in order to set this up, all we have to do is pinch these clamps on the side. There's some little rubber runners right here, and it sits nicely inside of there. So we're just going to put that on, and just carefully just let that sit nice and snug on there. So that is the very simple way to set up our burette stand. And remember, now what we have to do is we now have to clean and rinse this burette with the materials we're going to use for a couple of reasons. First of all, we want to make sure it's clean, but second of all, we want to make sure this head space is full of liquid. Right now the stopcock is open, and remember, when we do all this filling, we're going to do all of this at eye level. So I'm just going to move this out onto a stool so that I can fill at eye level, and then we'll keep going from there. All right, so in order to fill this, what we need to do is, first of all, we want to look at the bottom of the burette. And remember, at the bottom of the burette, we have that stopcock. When it's vertical like this, we know that it's open, so the liquid will flow through. So what we want to do is turn it horizontal. And in doing so, we've now shut off that stopcock. So nothing should come through when we fill into this burette. Now we want to make sure, sometimes because these stopcocks, if there's like a screw on this side, there's a little rubber O-ring on this one, but sometimes there's a screw here. If that's not fully tight, what happens is it can like leak out the side of the stopcock, and so it doesn't actually stop. So in order to prevent anything awry from happening, we're just going to put a small Erlenmeyer underneath there. We're just going to use that to catch anything that might happen to come off. Now we're set up that we can actually start filling. So the first thing we're going to do is we're going to rinse with water. Now remember, we do this at eye level. So these things are pretty long, so it takes a little while to pan up here for you guys. So we're going to use just a small thin neck funnel. It's just going to sit on top. And then we're going to rinse it twice. So we're going to put about 5 to 10 mils of DI water in here. And once we've got that in there, we're just going to let it drain through the tip. This way we can rinse out part of the burette. What I'm actually going to do here is I'm just going to rinse around the inside of the burette just a little bit. Try and rinse down the sides. Then what we're going to do is we're simply just going to let that drain out the bottom, and we let it drain out the bottom by just turning that stopcock so it's vertical. And you can see the liquid rushing out the tip. And we're just going to let that completely drain. All right, so now that's drained out, we want to reclose that stopcock. Then we're going to just refill it one more time with about 5 to 10 mils of water so that we can finish just rinsing this out. And we're going to do what we just did a moment ago, where we're going to just focus on the stopcock there. We're going to let that drain all the way through. So now we've effectively cleaned it out with deionized water. And once that's finished draining out, which looks pretty good right there, we can close the stopcock and we can dispose of that water down the sink. Obviously it's just water, you don't need any special waste. And we're going to place it back on there. Just going to raise that up just slightly. Now we're going to add some of our sodium hydroxide. So we've cleaned it out with water, but now what we need to do is we need to clean it out with the sodium hydroxide we're going to use. So we're just going to take some of our standard solution here, and we're just going to pour it into a beaker to make it a little easier to pour. When you use a volumetric flask, you notice there as it was pouring in, they tend to gurgle a little bit because the air can't get in very well, but it's much easier to pour out of a clean beaker. So now what we're going to do is we're going to use our beaker of sodium hydroxide. And we're going to pour in again. We're going to do 2 10 ml washes in the same way we did with the water. And by doing so, we can make sure that that tip is now getting filled with the system that we want to use. I'm going to stop this one just a little shy so it doesn't completely drain. Then we're going to do the same again. Going to add about 10 mils of our sodium hydroxide, and then we're going to drain it, but not completely. I'm going to leave just a trace in here. That way I know that the head of that, so this part down here, I know the tip or the head of my burette is now full of the sodium hydroxide. So when I come to fill that with my final material, I know it's good to go. So now what we're going to do is we're actually going to fill this burette, and we're going to fill it to somewhere around the 0 mark. You may not be able to see the markings very well, but the 0 mark is about here. So the 0 mark is here. So we're just going to fill to that point. And again, we're going to use a beaker because that's a much easier way of doing this. And once we've got it right around the 0 mark, we can make sure that the reading is on a line below the 0 so we know it's a real reading. So that's right around there. And then once we have that set up like that, we're then good to move that back into the hood and use that for our titration. One of the other lab skills or instruments that you need to be able to use, which is actually very valuable for titrations, is the use of a volumetric pipette. They come in a couple of different types. The one I have here, as you can see clearly from the view here, I have a volumetric pipette that has gradations on it with actual volumes. So you can actually put individual volumes all the way up to 10. Sometimes they have these bulbs that have calibration lines in them, kind of like a volumetric flask, and those ones have a very specific volume. But we want to measure up to 10 mils today, so we're going to use one of these volumetric pipettes. And what we have to do is learn how to use one of these. And typically the way we do it is with one of these bulb systems. Notice the bulb is detachable. Even though it gets stored with it on there like that, when you come to use it, you don't really want to have it like jammed on all the way like that. We're going to use it just to kind of sit on the top. And we'll show you how to work this here. So I just have an Erlenmeyer of water here that we're going to use as an example. So first thing we need to do is we need to actually put the seal end on the end of the volumetric pipette. And be careful when you're doing this to make sure that when you're holding glass and trying to push glass into something, one of the most common accidents in the lab is for the glass rod or a glass pipette like this. If someone does it further back, you can imagine you're likely to put some torque on or some shear on that pipette and it'll snap. And if someone's pushing against it as they're doing that, it'll end up cutting their hand, slicing it, or stabbing straight through their hand. So when you try to push glass into anything, you should make sure that you're holding it very close to where you're doing it. And when you do it, just very gently twist it and push it at the same time. So that way you're not putting all like on a on inline force. So now that should be on there pretty well. And what we're going to do is when we want to put the liquid in the pipette, we're simply going to put it inside the Erlenmeyer. And what we're going to do is we're going to hold the pipette in a clasp like that, and we're going to hold the bulb between our thumb and our first finger. And what we're going to do is we're simply going to just rest it on there just ever so slightly, just enough that we know we can get a good seal around that white piece of plastic. The reason we want to do it this way is because we want to eventually lift that off, and we're going to put our thumb over the top like that to hold the liquid in there. Kind of like when you put your straw in a drink, like at a restaurant, and if you put your thumb on it, the liquid stays in the straw if you lift it out of the liquid. Well, we're going to use that same principle here. So we're just going to rest that on top of there. And we're simply going to put that in the liquid. So this is just, so here's the bulb. I'm just going to put it in there just ever so slightly, enough that I can actually pull the liquid up inside. You can probably see that in the line there. And you want to make sure you go up past the 10, but do not let the water get in the bulb. Notice how I have it most of the way up there. So what I'm going to do now is I'm going to just slide that off and put my thumb on top. And the reason you go past the 10 is because obviously when you do that, you lose a little bit of liquid. Notice how in this instance, I still have a little bit more than 10 in there, which is exactly what we want. So I can now put the bulb on the bench. And then by just using my thumb, and you can use your forefinger too for this. There's a couple of different styles to holding one of these. I'm just going to gently lift my thumb up so we can see the liquid get down to the 10 mark. So you have to be, this is where it takes just a little bit of skill and practice to get this good. I'm just letting out a drip at a time until that meniscus sits right on the 10 line. So now what I have in there is I have 10 mils of liquid. So I have 10 mils of liquid in here now, so we can take a look at that up close. Trying to get you at eye level here. There you go, perfect. And then we would transfer that into the Erlenmeyer of choice. So that's how we use a bulb pipette or a measuring pipette like this. Alright, so now we have everything we need to start this reaction. We have a known sodium hydroxide solution. We have our indicator, in this case we're going to use phenolphthalein. We have an unknown acid, an unknown HCl system, and we have an unknown acetic acid or vinegar system. And what we're going to do is we're going to determine these two unknown solutions by titrating it with the known sodium hydroxide solution. So we've already set up the burette. We've already learned how to use one of these measuring pipettes. So now what we need to do is actually set the system up. So the first thing we need to do with any titration is to know what the initial reading is in that burette. So we're going to set that up now so you can see that. Alright, so we've set up for an initial reading on the burette here. You're right at eye level on the burette reading, so I'm just going to put my hand behind it so you can kind of see that line a bit more clearly. And maybe we can zoom in just a bit more here and get you a good view of that line. So you can see like the dark part of the meniscus almost shows like almost like a reflection, so you can pick out that meniscus pretty clearly with that view right there. All right, so take that as your initial reading in this first titration. And then we'll set up the rest of it. All right, so to set up the rest of our experiment, we need to, first of all, have our, I'm going to put a piece of paper down there so we can see the color change in our liquid when we put it in there. Then what we're going to do is we've got two Erlenmeyers. We're just going to call A and B because we're going to do 2 runs of everything here. So we've got A and we've got B. And the first thing we're going to do is we're going to take our unknown HCl system and we're going to use the pipette that we were just looking at a moment ago. So we're just going to put the plastic on the end. Remember, we're going to hold it in the air. As we put it in, we're just going to just gently just twist it a little bit. Just as to go in easily. And we're going to get our bulb ready. We're going to hold it between our thumb and our first finger, and we're just simply going to rest it against the end. Just enough that we can get some suction on there. And then what we're going to do is we're going to put our Erlenmeyer right next to the vessel we're getting everything out of. We're going to squeeze the bulb before we put it in there, and then we're going to just take up the liquid we need. I'm going to go past the 10. Do not let it go into the bulb though. Alright, so we have more than 10 in there right now. So all we're going to do is we're just going to let this down. Until we have 10 in there. You're a little bit below eye level, but you'll get the idea here. So I'm just gently letting it out. All right, now we have 10 in there. I'm just going to transfer that over. We just transferred that into the Erlenmeyer, which we've labeled A. So now we're going to recap our acid because we don't want anything to happen with that. We're going to take everything out of the way. We're almost ready to actually start our titration at this point. What we're going to do is we're going to put a couple of drops of phenolphthalein in there. Remember, we use this so we can witness pH changes. We don't need a lot of indicator usually. 3 to 5 drops is usually enough. We're just going to swirl that around so it's nicely mixed, and then we're going to place it underneath our tip. Now, in this titration, we're not going to focus on the liquid moving down the burette itself. Remember, as we drain this out of this stopcock here, the liquid level in this burette is going to move downwards. If you were standing right here, we've got to watch both at the same time. It's just a little tricky. So what we're going to do here is we're actually just going to focus on the actual titration itself. So remember, the correct operation is to swirl with your dominant hand and to use the stopcock with your other hand. So I want you to watch the color of that liquid. Remember, we're going to get some localized coloration at first. And we don't know how long it's going to take for this. So the first run, you've always got to go a little slower. And you can probably see some of that localized coloring as we swirl it. So notice I'm controlling the stopcock with my left hand, and I'm continuing to swirl as much as possible with my right hand. I want to really make sure I get that, I just want a light pink color. If I don't swirl it for a second, just let a couple of drops fall in, you can kind of see that pink color forming around where the drops are. And as that goes more, you're going to see that color become more persistent. If you followed the KHP titration, you've already seen this. So If you haven't, just keep looking right in the middle there where those drops hit. You see that local pink color forming? And when that pink color becomes more persistent after I've swirled it, because that's just like a localized pH change. If you swirl it, it kind of like brings that into the rest of the system. But when you start seeing that pink color holding on a bit longer and a bit longer, it means you're getting really close to that end point. So you probably have to slow down the rate of those drops. So I'm just going to slow that for a second there, because I think we're starting to get pretty close here. So I'm just going to add it dropwise here, and I'm going to be ready to turn it off the minute I see we need just a very faint pink color. It doesn't have to be like a deep, rich pink. Because phenolphthalein with an acid-base pH change here will end up being a pretty bright, hot pink kind of color. So titrations do require a little bit of patience, especially the first one. Since we're going to redo this, once we've got the data from the first one, we're actually going to be able to use that to do the second one and any other additional runs a lot faster. See now that when the drop hits now, it's a lot richer. That color's starting to be a lot more persistent now. It's lasting a lot longer. It's taking a lot more swirls to get rid of it. So it probably isn't going to take much more before that color change hits, and there it goes. That's right on the money. So that was literally like, it was colorless, and then one drop became pink. So when you're looking for the endpoint of an acid-based phenolphthalein indicator system, the phenolphthalein will go from clear to pink as you hit that end point of your system. So now we've reached the end point of our systems. This is for A. Just to kind of give you a sense of the color up close. So it's not super dark. A couple more drops, it wouldn't take much more. We can add another drop to C, but we need to take our reading first. So what we're going to do here is, so our titration is done. I'm going to pause it here and get you in position to be able to see exactly how much the final reading is, so we can determine how much of our sodium hydroxide we used. Alright, so we have the camera about eye level with the bulb. We're going to take it in a couple of notches here so we can see if we can get a good reading. We're still just a little bit far away, so let's just take it a little closer so we can actually get a good look at that eye level reading. So if you were looking at that right here in the lab right now, that is what you would see. If I just twist that around a bit, you might better get a better reading against that marking there. So there we go. So that would be our final reading for that initial titration. So when we go to run the second one, what we might want to do is run it down about a mil or so short of this point. We can just run it straight in knowing we won't hit the end point. So take that reading, so that's our first titration. We got our initial reading, this is our final reading, and we know how much of the unknown we added. So now we're just going to repeat this and see how close our data is. Okay, so I refilled the sodium hydroxide. We don't need to do the whole thorough cleaning and rinsing and then adding sodium hydroxide and rinsing, because we already have the system complete with sodium hydroxide. So all we need to do is refill back to the zero or near the zero. So that's what I did here. So just to kind of zoom in so you can see it a little better. And then we're going to zoom in so you can get your initial reading for the second run. So in case you can't see that, I'm just going to put something blue behind it. And you can see where that meniscus is sitting, and you can get your initial reading out of that. Now what we're going to do is we're going to set up the second Erlenmeyer so we can redo our unknown HCl. So we're going to move over there. So we need to get our second Erlenmeyer, and we're going to get our unknown HCl again. This was our completed one from before, so we're just going to put that to the side out of the way. And we're going to get our pipette and bulb, and we're going to get ready to transfer 10 mils again into Erlenmeyer B, our second run of this titration. So we're just going to put that below the surface of the liquid. We're going to draw up the 10 mils. Oop. We'll do that again. All right, so we have our 10 mil mark again. I'm going to try and get that roughly level for you, and then I'm going to just drain it down till we get to the 10. Notice how it's just very slowly moving. And once you're right on the 10, you're good. We're going to quickly transfer that over. And all we're going to do is just lift off our thumb from the top of that pipette and let the 10 mils out. Just touch against the side to get the one last drop off, and then we're good. We're going to tidy up our bottles, make sure nothing happens, put everything to the side out of the way. And now we're good to go with our next titration. So I'll just bring you out a little bit here. So to do our titration, we first of all need our phenolphthalein again. So we're just going to add 3 drops of the phenolphthalein in here. Oh, 5 drops. We'll cap that up. Just good lab habits. We're going to swirl our mixture here and we're going to add it underneath our titration, so we're good to go. Now, we have an approximate number from last time. So what we're going to do here is I'm just going to let it drain in pretty significantly towards that number before I start doing it very carefully. So you can't see the burette, but I'm going to add about 20 mils into here. I'm going to give it a little swirl on the way. I'm going to get ready to shut that off around the 20 mil mark. So that way, we're not at the end point yet, but I've already done a big chunk of the titration in basically 10 seconds. So now what we're going to do, now we're going to deal with this carefully. And we're going to add it dropwise. And we're going to swirl. I have an idea of where this is going to come out, so I'm going to be watching this carefully as we get close to that number. Very close. This is where fine control on this stopcock is really important, trying to get it just 1 drop at a time. Now you remember, when you're swirling this, do your best not to damage the tip of this burette. That is it's probably the next drop is probably going to do it. There it is. Literally 1 drop is all it takes. Just make sure that is thoroughly done. That is exactly on the end point. We couldn't do that any better. So it doesn't have to be a deep pink color. It just has to have that pink hue, which is why we put the piece of white paper underneath it, so you can kind of see that pink hue just a little bit better. See if you can see it on camera. It's a little tough to see, but that has just a slight pink hue. If I add 1 more drop to it, that would definitely go dark. In fact, we're going to add one more drop because it looks like that might have gone away. All right, and there we go. Literally one drop is all it takes. When you see it go from clear to pink with a single drop like that, you know you are right at the end point and you've done the experiment very well. So that was a very well done experiment. We can now set it up so that we can get our final reading on this. I'm just going to move you up there. All right, so I've moved the camera up to eye level so we can get this burette reading right here. So I'm just going to move us in closer. And then just so you can get a nice clear reading. I'll take you in just a bit closer here. It's almost cheating being able to use the camera in this way. So you can see those numbers pretty clearly. You can use that perhaps, or it might actually be clearer with the black line behind it. So we're just going to leave it like that. And you can make your assessment as to where you think that meniscus is stopping. And that is your final reading for the second titration. All right, so we've just finished our second titration of the unknown acid solution. We just got our final reading. So these two HCl systems have now been neutralized, and we can see their endpoints are pretty similar, pretty pink in both cases, and I believe we have good data for both. So we should be able to determine the concentration of that unknown acid solution. So we're just going to put those at the back. We'll clean those up later. Now what we're going to do is we're going to do an unknown acetic acid solution, which is vinegar. And what we're going to do first of all, because again, trying to get anything out of a volumetric flask is a little tricky, so I'm just going to pour about 40 mils into this beaker here. So it's a clean, dry beaker. I'm just going to then place that out of the way. And we have two more Erlenmeyers that we're going to use here. We're going to just label them A and B so we know which is which. Then we've got a clean volumetric pipette that we're going to use. So we're just going to take our bowl off the other one. And we're going to carefully now add it to this clean pipette. We're going to put our Erlenmeyer next to our sample here, right? And remember, whenever you transfer anything, you always try to keep the two vessels where you're transferring from and to reasonably close to each other so that you have less chance of spillage or drippage of the material. So I'm just going to put this in and try and go beyond the 10 mils. No. Didn't quite work that time. All right, so we have more than 10 mils in there, so now what we're going to do try and keep that at eye level for you. I'm just going to gently lower this. So lifting my thumb ever so slightly, so let it drip at a time out. This does take a little bit of fine control and a little bit of practice to get it right. And we're right on the line, and we're going to quickly transfer it over into our Erlenmeyer. Take the last drop, and then we move it to the side. So now what we're going to do is we're just going to clean up. We're going to put B out of the way, put the bulb over there, and we're going to put our acetic acid system next to it out of the way. Now I've already refilled the burette, but what I should do is let you get that reading, so I'm going to get that right now. All right, so we're at eye level after my refill of the burette. So we can kind of zoom in a little bit here and take a look at that initial reading. You should be able to see that. I'm going to put my hand behind it to see if that helps a bit. You can get that reading at the bottom of the meniscus there. Remember to read at the bottom of the meniscus. So that's the 0 line at the top of the screen. I'm going to leave you to get that reading. Make sure you think about that last digit of precision. If it's right on a line, it's 0. If you think it's right between two lines exactly, you go with 5 at the end. Just remember how to take that measurement. Okay. Alright, so now we're going to open the stopcock. And since we don't know what this one is, we're going to have to take this one fairly slowly. So we're going to do the correct method. We're going to swirl and we're going to add it at the same time until we start seeing a little persistence in the color. And then as we see that persistence in the color, we're going to start slowing down the rate of addition. So we're seeing a little localized pink in there right now from the phenolphthalein. Starting to persist a little bit. We're slowing the rate down just a bit so we don't go past it. Gotta make sure you're swirling it. Of course, you're always trying to make sure you don't knock against the tip of the burette. The pink is beginning to persist a bit more. It's taking like an extra swirl for it to go away. I think we're getting close. You should be able to see that pink forming right in the middle where the drop hits, and it won't go away until I swirl it. Sometimes these things take just a little longer than you anticipate. Or maybe you're a little further away than you think, but I believe this is starting to get close now. Probably a couple more drops. That is right on the edge. I'm thinking either one of the next 2 or 3 drops is probably going to be all it takes. So we're just going to carefully add these drops. Not one drop. See how it went from clear to pink? That is right on the end point. We're just going to sit here for a second to make sure that pink doesn't go away. If it doesn't, then we're done. Nope, there we go. So that's obviously persisting as pink. So we've reached the end point in this titration. So now we're going to get our final reading. Alright, so we just finished that titration. So we're just going to zoom in here and try and get the final reading on the burette after that. And should be able to see that You are right at eye level there. You're a little bit high maybe. Let's just lower that down just a bit. That's what we're going to do. Raise that up just a touch. There we go. Now you're right at eye level. I use the bottom of the meniscus. To get your reading. All right, so we just finished the first titration with the unknown vinegar solution. I just refilled the burette. So again, all I did was just add the sodium hydroxide solution back to a 0 point. So we're going to go ahead and get that initial reading now. All right, so this is for the fourth titration, the second acetic acid one. This is the initial reading. So we're going to zoom in on that meniscus so we can get that initial burette reading. That should be fairly clear right there. I'm going to put my hand behind it so you can see just a little better. Look at the dark line of the meniscus and see where it is. If you think it's right on the line, put a 0 in your last point of precision. If you think it's between, you can put a 5, or if you think you can estimate better, then do that. Alright, so that'll be our initial reading for the fourth titration, the second acetic acid titration. Alright, so now we just need to set up that final titration. So here's our flask B for the acetic acid. That's our acetic acid that we poured in earlier. Here's the same pipette that we used before. So we're simply going to do exactly what we did before. We're going to fill this up. We're going to carefully just place that bulb on top. And we're going to try and suck up 10 mils. We're going to go a little bit past it, remember. Not into the bulb though. So there we go. And then what we're going to try and do is get that 10 mils in there. I'm just going to gently lift my thumb to let that level down. See it coming into shot. Once we've got the 10 mils, we press down firm so we don't lose any. And then we're simply going to transfer into the Erlenmeyer. Touch the side, get the last drop. Move everything out of the way. And now what we have is we have our last 10 mils of acetic acid here. We're going to add a few drops of phenolphthalein. So make sure we have an indicator here. 3 to 5 drops is usually plenty. And then what we're going to do is we're going to set that up underneath our titration. Sorry, underneath our burette for the titration. So B is ready to go now. Let's give that a little swirl to make sure that phenolphthalein is well mixed. Now we have our initial data point from the first titration. So we can kind of let this thing go pretty fast at the beginning and get down to that point, and then for the last mil to 2 mils we'll add it drop wise until we find very carefully that end point. So I'm just going to add it in a pretty good clip here until we get down somewhere near our end point. Alright, so this is one of those surprising results where I looked at our data from the first run and it was a good 3 or 4 mils on from where we are now, but as you can see clearly we reached an endpoint here. So we're going to have to rerun this and see which data point was incorrect. It's very surprising to be that big a difference. 5 mils is a pretty significant difference in what we're anticipating. So either something didn't measure correctly or there was a contamination in one of the Erlenmeyers. So we're going to get a clean Erlenmeyer and we're going to reset this run. Right now the reading, I'll just give you the reading on this one. The reading is 27.15 mils. So 27.15 mils on this second run. But we're going to rerun this because if you remember taking the reading from the first one, it was a good deal bigger than that number. So we need to rerun this. So I'm going to go ahead and get a clean Erlenmeyer. All right, so let's clean this up. We're going to put B back there with our A for acetic acid. We're going to set up C. That is going to be our third run for the acetic acid. And what we're going to do is we are going to actually add just a bit more liquid into here. Just a bit more of the acetic acid. Then we're going to measure our 10 mils. Again, put the vessels close together. And then try and zoom in for you on the 10 mils. So you can just see it in shot there. I'm just going to carefully lift my thumb and get that line to drop down. See it coming into shot. That's right at the 10 mils. I'm going to transfer that into our Erlenmeyer. Take the last drip. Now we're just going to move everything out of the way. So we have sample C set up. We're going to add some phenolphthalein to it. And so that is ready to go. Now we need to just get our initial reading on the burette, which I've already reset. All right, so we filled the burette. Need to get that initial reading, so we're going to zoom in a little bit on that line for you. All right, so maybe put my hand behind it again to help with the color. So you can see where the bottom of that meniscus is. So you should get your initial reading for this, the third acetic acid run. And what we're going to do here is just go back down to the burette tip and actually run this titration. All right, so here's the sample C that we just set up. We're going to put that underneath. Now, I've kind of got a range of possible answers here. So here's what we're going to do. I'm going to run this one not as far as the second one, but we're still going to run the first part of it fairly quickly. We have a pretty good idea of where it started changing for the second run, or the B run as it were. And so I'm going to stop well short of that so we don't go zipping by it again in case that is the correct answer. If, on the other hand, the first one's the correct answer, we still have some room to play with here. So hopefully we don't get a third distinctly different answer, because that would be disappointing. So we're going to let this one run a little bit. Getting really close. It looks like that second run was the better answer, because we're right around that value. Remember that one was pretty deep, so we probably went a few drops past the end point. There we go. Just turned. So we're going to get a final reading on this, and we're probably going to have to run this a fourth time because it looks like our first data point was way off. Our second data point wasn't a well-run titration because we went right past it. Our third run was much better and is actually in the ballpark of that second one. So we're going to get that reading, and then we're going to set up one last run of this just so we get good data. All right, so let's get the final reading on this third titration. Try zooming in so you get a nice reading on that. The black background makes that nice and clear. And so that is the final reading of our third titration. So you can see by that value, remember I told you the second one was 27.15. This is obviously much closer to that, but that 27 feels like we kind of blew through the endpoint. So we're going to have to rerun this a fourth time in order to get two data points that we believe are reliable. The first one was off by so much that there appears to be something distinctly wrong with that value. And so we're going to have to come back to that and check it later on. Or we're going to have to throw that data point out and look at these ones that are much closer together. All right, so we just finished the third run. So we are now going to clean up C here. We'll put that behind A and B. And I've just filled the burette. We'll get the initial reading in a moment. But first of all, let's set up our fourth run here. So we're going to need our acetic acid. We're going to need our pipette. And we have one more Erlenmeyer here. We're going to label this D. We're going to transfer the 10 mils like we have been. All right, so once again, we're going to drop this down. So that line hits the 10 mil. So I'm just gently raising my thumb. No control at the end. We have our 10 mils. So we're simply going to transfer that into our Erlenmeyer. Catch the last drop on the edge, put everything away. So we're just going to put everything to the side so nothing gets damaged. Then we're going to add our phenolphthalein. We're just going to add about 5 drops again. Give that a little swirl so it's ready to go. So D is ready to go. First of all, we need to get our initial reading for the burette, so we're just going to pause and get that. All right, so we're just about zoomed in on our initial reading here. I'm going to put my hand behind it so we can see it a little better. We're going to see if we can get a slightly better reading on that. You're right at eye level, so you should be able to get that initial reading. This is for our last, hopefully, acetic acid titration. So now we'll go down and we'll run the titration. All right, so here's our sample D that we just made. We're going to put that underneath. And we're just going to drop the burette just down a tiny bit. There we go. I want to make sure it's just inside the neck of the Erlenmeyer so we don't miss any drops. And then we'll zoom in so you guys can see any color changes. We're not going to watch the liquid level, but I'm going to use that last run that we just did as my guide. So the run C is going to be what I use as a guide to run this one a little faster. So we had the amount for that, so I'm just going to run it down to about 2 or 3 mils shy of that, and then we'll add the last couple of mils in a dropwise manner. All right. So now this last bit we're going to do a little more carefully. We're getting close. The pink was fairly persistent on those last couple of drops. Probably another 1 or 2 drops and we'll probably have this endpoint. Probably the next drop. There we go. So we have that slight pink color. You can just about make that out on shot. So now what we need to do is get our final reading for that. All right, so we're in shot to try and get that last reading. So let's take a look. We zoom in, get a pretty good clear view of that at eye level. So this is your final reading, and you can see that gets pretty close to run C. So I really think that when we're looking at this data, we really have to throw out run A. That was clearly an aberration. It was way off the mark. Run B was in the ballpark, but because I wasn't anticipating it, stopping that early, I blew right through the endpoint, and so we ended up at 27.15, which is a good mill further on. So we probably really can't consider that to be a precise reading for, or sorry, an accurate reading for this unknown system. Run C and run D were both run off of B being the crude one. So now looking at this, you can see that run C and D gave us some pretty similar values. So when we're doing our analysis here, we're really only going to rely on the data from C and D. And in our explanation, we would explain why we're throwing out runs A and B on the grounds that they are clearly not a good representation of this endpoint. And that would be the last part of this experiment.